Okay, good morning to all of you. Here, this is Praveen Shankar. Our paper is about a novel approach to minimize the energy consumption using task scheduling in cloud data centers. So, in this research work, what we have tried to implement it. So, with the help of task scheduling algorithms, three different task scheduling algorithms, we have analyzed all these three task scheduling algorithms, and we are trying to minimize the energy consumption in the data centers, cloud data centers. Hope already we know what is cloud data centers and how the energy is being consumed in the data centers and all. So we will see our paper, right? So our ultimate intention is to minimize the cloud data center power consumption, which means the carbon emission of all the devices in the cloud data centers. So the data centers play a vital role in modern computational environment. So the data center actually made up of servers, storage devices, cooling equipments, and power delivery equipments. And by combining all these devices and equipments, we can have the services of software as a service, infrastructure as a service, and platform as a service. So, because of all these equipments are the electronic devices. So, all electronic device emits the carbon, right? Which means it emits the carbon. So it is going to be a huge problem for the environment. So your environment will become very heat, right? So it is going to be the huge problem for the environment, and there may be a possibility of it will affect the global warming, right? So we have tried three different task scheduling algorithms to minimize these carbon emission and power consumption and heat production in the data centers as much as possible. So in this scenario, we have taken three different task scheduling algorithms, and we have tried one by one with the simulation software, and we have tried to prove that one algorithm is has got the less power consumption. So these are all the three algorithms, that is TPPC and RASA and PALB. So about all these research work, we will discuss one by one in all the upcoming slides. So our ultimate intention is to reduce the power consumption in the data centers, right? So with the help of task scheduling algorithm. So how to reduce the power consumption? Because by reducing the power consumption, the carbon emission in the data center also it's going to be reduced. Then by doing these two things, we can improve the performance of the overall cloud resource allocation process and overall efficiency of the cloud environment, right? So this is for object 1 and object 2 and object 3. So we have tried to prove that we have tried to prove that one among this algorithm is given the optimized results, right? So our proposed research tells we have taken the CloudSim software and Cloud Analyst software. Hope everybody know the CloudSim with respect to the cloud simulator, right? So the Cloud Analyst is one of the graphical user interface with respect to the CloudSim. Both are operating in Java programming, right? So we have taken the simulation softwares. So we adopt three different algorithms in cloud simulation softwares, and we have tried one by one, right? So the results are tabulated and analyzed each other. So first algorithm, what is the power consumption? What is the time constraint? Second algorithm, what is the power consumption? What is the time constraint? Third algorithm, what is the power consumption? What is the time constraint? In addition to that, we have taken as the cost and resource utilization, right? So all these three are analyzed one by one. So now let us go for the next slide, right? So in cloud system, as we are seeing in the screen, 40% of the power, that is energy consumption, is done by the server, right? So server emits some carbon, right? Because of that, 40% of power consumption is done, and 40% of power consumption is done with the help of cooling system, right? So we need to spend much for cooling system. Why? Because everything, all servers, racks, all devices or the electronic device. So all electronic device emits some amount of power, right? So remaining 10 percentage only we are having for power supply, and 5 percentage for communication devices, remaining 5 percentage for storage devices energy consumption. So in this research, what we have tried to do is we have just have taken the server energy consumption constraint, and we have tried to optimize the server energy consumption with the help of task scheduling algorithm. So in this aspect, three different task scheduling algorithms are taken, and we have tried to reduce, right, these task scheduling, so these power consumption in servers, right? So we'll go for the next one. And in server energy consumption, there are 6 different types, right, in server energy consumptions. So before that, overall energy consumption of the data center. So in this, we have taken as server energy consumption. In the server energy consumption, what are all the possible ways to consume the power, right, or energy in the servers? So first one is the energy produced by ideal PM. So that physical, so those some of the physical machines are kept as ideal. Even though it is kept as ideal, some power is being provided, is being consumed by that physical machine. So that is one type of energy consumption, and the virtual machine energy consumption for application execution. So hope there'll not be there should not be any explanation for all. So we are assigning a process that virtual machine is executing a process. The third one is energy generated by the internal communication, then energy generated by the external communication, then physical machine baseline energy consumption, then energy consumption for mode switching operations, right? So these are all different energy consumptions in server, right? Server energy consumption. So with the help of the taken algorithm, we have tried to reduce all these 6 different types of energy consumption in the server energy, right? So first, what we have done is, so we configured the CloudSim and Cloud Analyst software, right? So hope all you know that what is Cloud Analyst, CloudSim software. So it is just a software simulation tool with the help of CloudSim and Cloud Analyst. We can simulate the cloud environment, right? So first, we are going to initiate the Cloud Analyst. In this, what we have done, in the sense, it is basically run in Java programming, Cloud Analyst. If you want to adapt a new task scheduling algorithm in Cloud Analyst, CloudSim, in the sense, we have to write a Java code for that particular algorithm, right, in that environment. So we have to run the CloudSim simulator. So automatically, the algorithm will run. So the results will be generated in terms of Cloud Analyst software. So we can get as a GUI, graphical user interface results in terms of graphs and in terms of statistics, right? So then first we are configuring the Cloud Analyst. Then during the configuration, we have to give the number of users and number of brokers. Then we have to fix the data centers, right? After that, we have to include the proposed task scheduling policies in the data set. So here we have taken 3 different task scheduling policies. We have executed one by one, right? So measure the energy consumption and absorb the results. So each and every task scheduling policy with respect to the taken input for number of virtual machines are calculated, which is measured, and it is tabulated, right? The results are recorded in the table, right? So the comparative analysis of all these 3 task scheduling algorithms are analyzed each other. Then finally, we conclude that which one is the best one, right? So this is the proposed system architecture. So as far as the proposed system, architecture is concerned, so cloud users give the task to the cloud system, right? Which means they are coming for subscribing the cloud resource. So initially the user request, which means the tasks are given to the traffic manager in the cloud. So the traffic manager again gives the results, the request to the load balancer. The load balancer again give the request to the data center broker. So the data center broker will provide the request to the cloud controllers. So finally, the cloud controller will allocate the request to the available resource, which means the data center resource. So this is what exactly happening in our proposed methodology. So in this process, we have tried this proposed approach for three different types of algorithms. So what are all the algorithms? So what are the algorithms we have taken and we have tried? First one is two-phase power convergence algorithm, that is called as TPPC. Then RASA, resource aware scheduling algorithms. Third one is power aware load balancing algorithm, right? So these three algorithms are checked in the CloudSim simulator and Cloud Analyst simulator one by one, and the results are tabulated. And from the results, so this is the first diagram, is the simulating environment, and second and third diagram are the some of the representation of the results, right? So these are all the real-time cloud simulation environment, and from the simulation environment, we got some results as I already told you. First algorithm is taken, that is applied for the environment, so results are absorbed in terms of power consumption, and in terms of cost, and in terms of resource utilization. So these are all the comparative analysis of the power consumption of these three algorithms and cost estimation of these three algorithms, and total virtual machines required for these three algorithms, then resource utilization of these three algorithms, right? So when compared with all other results, in terms of power consumption, RASA algorithm, it gives the minimum power consumption when compared with all other algorithms. But in terms of cost and in terms of resource usage, in terms of cost, PALB gives the better one, and in terms of resource usage, the RASA gives the better one. So we are going to take this as three different scenarios. So as far as our proposed approach is concerned, only based on the power consumption, right? So the power consumption is concerned, we are going to conclude that RASA algorithm is going to be the better one when compared with all other algorithms. So with this, we conclude our results, right? So what we have done in our research is we have taken three different task scheduling algorithms, and we have done the experimentation. We have tried to prove that RASA algorithm is the minimum power consumption algorithm when compared with other two algorithms in the existing cloud data centers. So thank you all of you. Thanks for listening.